I'm back. I'm going to do one more question about hyperbolas here, and this is one of the complete the square questions to transform an equation that is in general form to standard form, and this is for a hyperbola. And it is a little bit trickier because of the signs involved, so let's just go ahead and get started. The way you start is the same as you would for a circle or an ellipse. So we want to gather our like terms together and move the constant to the other side. So this would be x squared plus 10x, and then minus 4y squared. There's the difference. There's a negative on one of these squared terms, plus 64y. And then let's move 375 over to the right, making that a positive 375. All right, so you can tell we've got a little bit of work to do. This part of the equation is ready to rock and roll with complete the square. This one is not, all right? So we can go ahead and work on this part, and we will adjust the middle as we get there. So remember, when you're completing the square, you want to have a coefficient of 1 on your squared terms, and we do on this one, so we can go ahead and think through this process. So we want to take half of our middle term here, which is 10, and we want to square that result to get 25. So we are adding 25 to the left, and that means we're going to add 25 to the right. All right, that one's not too bad. All right, here's where the work comes in though, because we do have this negative 4 coefficient on y squared. So, Miss Brown, what do you do when it's a negative? Well, you got to deal with it, and you got to factor it out. Not only is it negative, but it's not a 1. So instead of factoring out just 4, like we would have with an ellipse or even with a circle, we have to factor out negative 4. So minus 4, and we are going to figure out what is remaining before we complete the square. So if we factor out a negative 4 from this term, we'll have y squared. And then 64 divided by negative 4, which is technically what you're doing when you're factoring out, should be a negative 16. So yes, the sign changes. All right, so once you've done that, you are ready to complete the square with that particular part. So we want to take half of our middle term again. So half of negative 16 is negative 8. Then we want to square that term. So that becomes a 64. Now, inside of the parentheses, we are adding a 64. But remember, on this side of the equation, we have factored out a negative 4 previously. So what that means is that this is really a negative 4 times 64 sitting on this side. So that's what we have to add over here. So negative 4 times 64, whatever that is going to be. And I need a calculator for that part. So 4 times 64. And it is a negative 256. So it may look unbalanced, but technically, remember, this number, if you distributed that back through in those terms, it would also apply to the 64. And you have to basically add the same number on both sides, even if it's a negative. All right, so we're keeping this thing balanced. So let's keep going. Here on the left, we're going to factor this, or think about how you would factor it, or write it as a binomial squared. A lot of you are getting really good at this, but I will still go ahead and do that in between step. This would be x plus 5 and x plus 5. Factors of 25 that add to be 10, and that is the same as x plus 5 quantity squared. That looks good. It's looking like that standard form that we want. Okay, yes, bring down the 4 and the minus, and then do the same thing for your y's. So this would be y minus 8 and y minus 8. Factors of 64 that add to give you negative 16. And then that's the same as y minus 8 quantity squared. Okay, it is a mystery right now what this number is going to be, but let's add it in the calculator and see. So 375 plus 25 minus 256. I'm getting 144. That's a good sign. That's usually a number we see in these equations a lot. But even if it wasn't, it doesn't mean you're doing something wrong. It just means it's maybe not what you expect. All right, so we're almost there. What is the trademark of an ellipse and a hyperbola equation? They are equal to 1. The only difference is one's got a minus and one doesn't. So we're going to do the same thing we did for an ellipse equation. We're going to force this to be 1, so we're going to divide both sides by 144. So our final answer would be x plus 5 quantity squared over 144 minus, now let's reduce the 4 over 144. So that leaves us with a 1 on top and a 36 on the denominator. and then we're equal to 1. So there you go. That's a hyperbola equation transformed from general to standard form.